Unit 12 is going to be very interesting because we're going to handle it differently than we have other units, and we're also going to be doing a very different topic than what we typically do in math. So it's all about something called geometric construction. So in 12.1, we're going to start off with I can understand and use the vocabulary and tools for geometric construction. So again, the word that's going to go here is constructions. So we're going to be constructing things here. So geometric constructions. And the warm-up is just a reminder about some vocabulary that you've learned before, or maybe you haven't learned before and it seems really confusing. So an integer is, hopefully you remember what these are, they are the positive and negative whole numbers, including, and a lot of people forget this, including 0. So positive and negative whole numbers including 0. Now this next one, you may or may not know what it is, but I'm sure you've all seen one of these. It's called a sphygmomanometer. Sphygmomanometer. Any idea what that is? Well, it's actually a very simple idea. It's just a blood pressure cuff. Okay, when they measure your blood pressure, they use a sphygmomanometer. All right, now the point of this warm-up question is that if you know the vocabulary, words and ideas go from really difficult to understand to really easy. So if you hear the word integer, sometimes people freak out about that, but we're just talking really nice numbers, positive and negative numbers, whole numbers including 0. And a sphygmomanometer, nobody ever calls it that, they just call it a blood pressure cuff, so it's not anything complicated. So the same idea is true when working with geometry and constructions. Now we all know that geometry is the study of the properties of points, lines, and planes, and shapes. And when we construct figures in geometry, we're going to draw these shapes, these angles, and these lines really accurately using only a couple of tools. So we're only going to use something called a compass, okay? Not a directional compass, but a drawing compass. A straight edge, not a ruler, but an actual straight edge, and a pencil. Now, I want you to put this right here because this is really important. If you use a sharp pencil, it makes things a heck of a lot easier when we're doing these constructions. Now this is really the purest form of geometry because we're not going to use any numbers. There won't be any measuring things in the usual sense of the word. What we're going to be doing is we're going to be making copies using just these basic tools of a compass, a straight edge, and a very sharp pencil. So let's make sure we know some of this common vocabulary that we're going to be using when we talk about geometry and doing some of these constructions. So the first thing is a point. A point is simply a location. A point has no size. It doesn't have any dimensions to it. It has no width, length, or depth. So when we do something like this, we would have maybe a point right here, and we usually label it, so like we'll call that one point P. Let's talk about a line. A line is a straight, continuous set of points that extends forever in both directions. It has one dimension. That one dimension is just its length. Okay? But that length is infinite. It goes on forever. Okay, so infinite here. So let me show you an example of a line. A line would look like this. There are different ways that we can label lines, but normally we've got 2 points on them, and I'm going to call these A and B. And the notation that we'd use for this would be AB and then with a line over the top of it. Okay, now a ray is a line with one endpoint. It still has infinite length. So it would be something like this. So I'm going to head it off in this direction. I'm going to have the endpoint here be C, and then another point on the line be D. So the notation that we'd use for something like that would be this. It would be ray CD. And then a segment is a line with 2 endpoints. It's just one chunk of a line, one segment of a line. Okay, it has finite length. Okay, it doesn't go on forever, so it's something like this. So it would start right here and end right here. So we would say this is E, and this is F. So we would say that this is segment EF, and notice that we've got a little line segment above that. Now, an angle is formed by 2 rays or 2 segments, and they have to share a common endpoint. So that would be something like this. So we're going to have a ray heading off in that direction, a ray heading off in this direction, and I'm going to label a point over here of A, and then here of B, and then here of C. And the notation that we could use for that, and we're probably familiar with this, is we could call this angle B, or we could call this angle ABC, or we could do CBA if we wanted to. Okay, and that brings up the next thing. You'll notice that we labeled this according to this corner point right here. This is a vertex, so the common endpoint, so in other words, the shared endpoint, I'm going to put shared right here for common. It's the shared endpoint of the sides of an angle. shared endpoints of the side of an angle. So this right here is the vertex of that angle. So this right here, I'm just going to do this. So we've got a vertex right there. And it says the plural is vertices. That's how we do the plural of that. And a vertex, sometimes we'll just call it the corner. So this is the corner of the angle. We could say that, or we could call it the vertex. Okay, so let's talk about parallel lines. Parallel lines, they're lines on a plane that never intersect. They never intersect, and they're always the same distance apart. So I'm going to draw two parallel lines like this. There's a line right here, and here's a line right here. And I'm going to label this one as L and this one as M. And those two lines are parallel. We could say it like this. We could denote it like this. We could say line L is parallel to line M. And then we could also put some little marks on here. If we put some arrows going the same direction, then that indicates on a diagram that those are parallel. Now let's talk about perpendicular. Perpendicular, those would be two lines that meet at a right angle. They meet at a right angle. And of course, a right angle is 90 degrees. And the concept of perpendicular, it extends to more than just two lines. It extends to other shapes, as we might see a little bit later on. Let's talk about a bisector. A bisector is something, usually a line, that cuts an object into two equal parts. So bi means two, so it's going to cut something into two equal parts. And an angle bisector cuts an angle in half. Of course, that makes sense. And a segment bisector cuts a segment in half. So let me show you what the two of those would look like. So let's say that we had an angle. Oh, I forgot to do perpendicular. Let's do perpendicular like this, and then we'd indicate that those are perpendicular there. Okay, for an angle bisector, let's say we have an angle like this. The bisector would be something that goes right in the middle here, and it cuts it in half. And I can indicate that by putting an arc here and an arc there. I could do a dotted line, or I could do a solid line. Wouldn't make any difference. The point is those two are exactly the same. And if I did a segment bisector, we would cut this in half, and it doesn't have to be kind of perpendicular or anything like that. All I have to do is mark that the two of those are congruent. Okay, which brings up the next word, congruent. So figures are congruent if they have the same size and the same shape. So exactly the same size and exactly the same shape. I'm sure we've talked about this before. Congruent is the geometry word for equal. Angles that have the same measure are congruent. And segments with the same length are congruent. So as long as they're the same size, if we're measuring an angle, we'd measure how many degrees it is and that sort of thing. And if we're measuring a segment, we'd be measuring the length. Okay, so let's come down here and talk about the last part on this side of the page. It says an acute angle. It's an angle that measures less than 90 degrees, but more than 0 degrees. So something like this, that would be an acute angle, maybe a 45-degree angle or something like that. A right angle measures exactly 90 degrees. So the way we'd make a right angle would be this, and we'd indicate it like that. A good reminder is, remember, we always go by the way things are stated, not by the way they look. So I told you this is an acute angle, and we can tell by that little mark of a square right there that that is a right angle. An obtuse angle measures more than 90, but less than 180 degrees. So that would be something like this maybe, okay, where we've opened up to be more than 90 degrees. So we've got acute right here, we've got right here, and then we've got obtuse right here. Now the last one on this page is a straight angle. A straight angle is an angle that measures exactly 180 degrees. So it's basically a straight line like this. So if we put a vertex right there, for instance, we'd have 180 degrees on this side, and we'd also have 180 degrees on this side, which kind of makes sense because we've got a 360-degree arc all the way around. Okay, let's take a look at the other side. Let's talk about some of the shapes that we're going to be dealing with. Let's talk about polygons first. A polygon is a closed plane figure, so it's a flat figure with at least 3 straight sides and 3 vertices. If we have 3 sides, it's called a triangle. If you've got 4 sides, then we call that a quadrilateral. Quadrilateral. Lateral. Okay. If it's got 5 sides, then it's called a pentagon. Pentagon. If it's got 6 sides, then it's called a hexagon. And you might know some of the others when it continues on. So 7 sides, heptagon, 8 sides, octagon, and so forth. So we could have a triangle like this. We could have a quadrilateral, doesn't have to be anything fancy like that. We could have a, let's see, we've got a pentagon, so 5 sides. Kind of got to be careful, make sure we get them all. And then I'm going to draw a nice hexagon right here. So I'm going to draw it so that it looks like this. nice as I possibly can. So there's a hexagon because it's got 5 sides. And that brings up this next one, a regular polygon. It's a polygon where all the angles are congruent and all the sides are congruent. So a square is a regular quadrilateral. So a square is a regular quadrilateral. So if we were to draw something like this, all the sides would be equal and all the angles would have to be equal, so they'd all have to be 90 degrees. And this is the way we mark those. So I'm going to mark this hexagon up so that it's a regular hexagon. I'm going to put an arc in each one of these. So that's going to tell anybody looking at it, even if I didn't draw it perfectly, that all of those angles are congruent and all of those sides are congruent. So that's going to make a regular hexagon. And then a square is a regular quadrilateral. Now let's talk about a circle. A circle is a set of points that are equidistant from a center point. And we all know what a circle is. So a circle looks something like this. So we've got a circle. All of these points are exactly the same length from this center point right here. So I probably ought to move that over just a little bit, make sure that it looks right. The central point is called the center, of course. And the distance from the center to the points on the circle is called the radius. So we're talking about the distance from the center to the edge. So we're going to go from here over to there. So we call that r for the radius, okay? So the notation that we use sometimes is we might say this is going to be center, so we'll put an A there. We'd say circle A or something, or we could use the word circle. So this is circle A, and there's the radius right there. Let's talk briefly about what a chord is. A chord is a line segment inside a circle that touches 2 points on the circle, 2 points on the circle. So this would be a chord if we did something like this. If we went from here over to there, that right there would be a chord. I'm going to draw an arrow right there, and we're going to write chord. I'm going to draw an arrow right there, and we're going to write radius, just so we don't forget that. And then let's talk about a diameter. A diameter is a special chord that passes through the center of the circle. It passes through the center of the circle. So there's nothing really special about this chord because all it does is just go from one side to the other. But if we happen to go from one side to the other, if we do a chord and it goes right through the center, then we call that a diameter. Okay, we call that a diameter. All right, now the length of the diameter is 2 times the length of, well, the radius is from the center to the edge, and the diameter is all the way across, so it would be 2 radiuses, or 2 radii. So the length of the diameter is 2 times the length of the radius. Okay, and then an arc is a piece of a curve that is part of the circumference of a circle. Now remember, the word circumference is the distance around the outside of a circle. It's a fancy word for the perimeter of a circle. So if we have an arc, it might be something like this. Like, let's say we have a center right here, and then an arc would be out here. It would just be a piece of it, okay? So this is just an arc. It's a piece of the circle that would go all the way around here, something like that. Okay, now a tangent is an interesting thing. It's a line outside the circle that touches the edge of the circle in only one place. So I'm going to draw a tangent on here. A tangent would look something like this, okay? So it goes like this, and then a tangent is perpendicular to the radius at the point of tangency. So if I were to draw a radius right over to here, it's got this interesting property that it actually meets it at a right angle. So we've got chords and arcs and diameters and radius and tangents and so forth. And then down here we've got the last thing that we're going to talk about, and those are constructions. So a construction is drawing and copying geometric shapes and figures using only a couple of tools. So we're going to use a compass. Use a compass and a straight edge. Straight edge. Okay, that's all one word. And all the measurements are performed without using numbers. So we're not going to use any rulers or anything. So we're actually not going to use any devices like this. Many constructions rely heavily on, let's write this word, congruent segments and congruent triangles for their precision. So we're going to learn a whole lot about constructions, and we're going to be doing a few of those in just a second. But what I want to take a look at here before I switch over and display this a little bit differently is the main use of a drawing compass is to measure distance. The main thing that we do with a drawing compass is we measure distance. So on a compass like this, which we're not going to use, this is the center point right here, and then we'd put our pencils in one of these 2 holes right here. What we'd be doing is we'd be measuring this distance right here. That's what it's there for. We don't really use the rulers on those at all. Okay, and then over on this compass right here, the way we measure distance is this right here. So this is the distance that we would measure using that type of drawing compass, and this is what we're going to use. Now, some compasses have this little adjustment knob and some don't. Some of them just have a little a screw right here that you can use to increase the tension there. If it gets a little loose and floppy, then you can always tighten that up with a screwdriver. Now, the main use of a straight edge is exactly what it's kind of sounds like. It's to draw straight lines. It's to draw straight lines. Now, these are pretty simple tools, but they actually take a little bit of practice to get used to. So what I'm going to do is I'm going to switch over, and from now on you're going to see most of this just instead of a screen capture, you're actually going to see videos of me doing construction on paper. So let's switch over to that. All right, so I've got a camera set up so that you can see what's going on here, and I've got a couple of tools. So the first thing I've got is I've got a compass with a mechanical pencil in here so I don't have to worry about sharpening. So that's going to be right here. I've also got a straight edge that we'll use to draw some straight lines. I've got another compass that I'm going to take a flare pen and I'm going to put it in here so that I can use that, and I'll tighten this down and that'll make it a little bit easier to see. We'll kind of see how this goes and see what we need. And then I've also got another marker that I can use to make lines, and I've got a mechanical pencil. So we're all set to go here. Now what we want to do on this example here is we want to just basically carve out and trace out these circles. So I'm going to go ahead and take this one right here. And what I'm going to do on this one is we're going to take this center point, we're going to put it right there. And then I'm going to measure, so I'm going to adjust here so that this is right on that arc over here. And then it says I need to go ahead and complete this. So I'm going to start right here. And again, when we're using this, what we normally do is we normally tilt this just gently in the direction that we're going to go. So I'm going to go around like that and just slowly. You have to kind of balance the pressure between the center point and the other end with the pencil on there. And we'll go around like that. And there we go. And you'll notice that we ended right in the place where we started. So that's pretty good. Looks good there. I'm going to switch over to the other one for this next bigger one on B. So what I'm going to do here is I'm going to make sure that the point lines up with the center point right there. So I'm going to go ahead and put that there. And I'm going to mention this again later on. This normally works well if you've got a flat surface and then you've got a couple of pieces of paper underneath as kind of a cushion. So I'm going to stretch this out here, make sure that that's the right length. Now with this one, what I'm going to do is I'm going to just go like that, and I'm actually not going to hold this up here at the point. I'm just going to hold it right over here so that I'm keeping a lot of pressure on the center point, and I'm just going to go like that. Now sometimes all you need is just a little tiny arc, and that's all we're after on this one right here. So that looks pretty good. Okay, next thing we're going to do is we're going to use a sharp pencil. Remember, we always want to use a sharp pencil. And we want to use the straight edge to line this up. So I'm going to line this up here, and here's kind of the best technique to use, I think. I'm going to go ahead and take the pencil before I put the straight edge next to this, and I'm going to put my pencil right there. Some pencils or pens or whatever, they've got different thicknesses. So what I'm going to do is I'm going to make sure that that's sitting right next to it, and then I'm going to kind of gauge how far away the straight edge has to be. I'm going to move this side a little bit closer. I think I'm in pretty good shape there. So I'm going to go ahead and draw this line, and you'll notice that it matches up perfectly. Center of B to center of A. Now on CD, I'm going to use a marker on this one, and markers are a little bit different, so I'm going to have to be careful with this one. I'm going to hold it about where D is, and then I'm going to put this right up against it so it looks like it's in pretty good shape. Now on purpose, I'm going to do this. I'm going to make it so that it doesn't go through C. So I'm going to make it go like that, and you can see that it doesn't go through the center. So what I need to do is I need to readjust. And one thing that you can do sometimes is you can actually adjust the angle of the marker or the pencil that you're using. Strongly recommend pencil. I'm only using marker just to make this appear a little bit better on the screen. So then it goes through there. So if you do make a mistake, just erase that, and then you'll be all set to go. So I'm going to go ahead and flip this page over. I'm going to take a quick look at some of the assignment. So on the assignment, there is a part of this that's just it's just a crossword. It uses some of those geometry vocabulary words that we talked about. So we've got the across and down. If you get those figured out, you're in great shape. There are some really good questions down here on 21, 22, and 23. But what I'm really interested in practicing is this stuff right here. So this is the second page, and it's got problem number 24 on it. And I'm going to hopefully, I know you can't see this whole thing all at once, but we want to make sure that we read the instructions really carefully. So read each one of those, read each one right here, and basically what we want to do is we want to make a copy of this on the next page, and it says start with the big circle, circle A. So what I'm going to do is I'm going to grab my compass right here. I'll grab the one with the marker in it. And we want to start with A, so we're going to put the center point right here, and then I'm going to go stretch this out so that I'm out right here. Okay, so we're right there. Looks like we're in pretty good shape. I've measured that distance. And then we're going to go to the next page here, and we're going to apply some very slight pressure on the center point. And then we lightly go through, and I'm going to go around this entire thing. Again, I'm tilting this in the direction that I want to go. And swing this all the way around, all the way to that one right there, and it looks like it's pretty good there. Need to finish that off, so I'm going to come around here. That looks pretty good. So again, if you don't maintain gentle pressure on that center point, it's going to get messed up a little bit. It might move around, and then you've got to readjust it and try again. And again, if the compass seems a little bit loose, you can tighten that screw right there. That'll make things pretty tight so that it'll stay right where it needs to be. Okay, and then down here on the bottom part, what we want to do is we want to make some straight lines to connect those. So again, this is just practice. So pick any points you want. So I'm going to pick C and D here. And again, I like the technique of putting a pencil right on that dot, kind of judging how far away the straight edge needs to be. That looks pretty good right there. And again, if you need to angle it this way or that way to make it work out, that's fine. Just make sure you maintain that angle as you go from one end to the other, and make sure you keep some firm pressure on this straight edge so that it doesn't move. And there we go. So you just want to practice a couple of those. We've got a long one right here from G to E. And again, if you put your pencil right here, get it nice and straight there, judge how far away that needs to be, and then make sure that the other end is just about that far. And again, if you need to angle it one way or the other, as long as you make sure you keep that same angle, then you should be in good shape when you connect those. All right? All right, and then the last part of this, let's see what we've got here. So on the last part, we've got a Stegosaurus, and I know you can't see the entire thing all at the same time because we've got this landscape version here. So what we want to do is we want to take our compass and we want to stretch it out to this distance, and we want to make the first two spikes on this Stegosaurus, we want to make them that long. So I'm going to go ahead and grab this guy right here, and I'm going to measure it. I'm going to mark it off so I've got the center point over here. So we'll have the center point right there, and then we'll make sure that it's the right distance. Looks like we're in pretty good shape there. Yep, maybe a tad longer. Looks like we're good there. Now I'm going to take this, and again, like I said before, sometimes if you just put the center here and you can hold it with one hand, all we want to do is just put a little arc right there, just a little mark, and we don't want to erase our compass marks, so we want to leave those there. So I'm going to come down here, and I'm going to lightly mark right there. And at the same time, since I know I've got to do two of these in a row, I'm going to go ahead and mark this guy right here. And looks like they did intersect there, so I'm in good shape. So I'm going to come back here, grab my pencil, and then I'm going to go from the center of this dot right here to that intersection point. So I'm going to go and see how I'm not quite on there. So I'm going to move that over just a little bit and then check it. It looks like I'm pretty good. Okay, so we'll come over here. Center point right here, and then looks like I'm in pretty good shape there. Hold that steady, and then we'll keep doing the same thing. I'm going to have that center point there, and then over to here, and we'll line up that center point again right there, and go to the center point over here. So we'll go like that. Now, please don't erase your compass marks, because then it makes it so we can see this. It would be worth talking about why this works the way it does. So what we've done here is when we set this compass to this distance right here, we're basically making an isosceles triangle. These two sides are the same because they're the radius of that circular arc that we did there, and those two are the same. So these two spikes are going to be the same. The next 5 are going to be the same. They're going to be a little bit bigger, and then the last 5, they're going to be a little bit smaller, but they'll all be the same. All right, good luck with that. Again, this is basically just about practicing using the tools.